Question 3 looks at a man doing pull-ups. First stage, second stage. In both diagrams the man is stationary, so this bit of information here is absolutely key, but it's really easily overlooked. What you need to remember that if an object or a person is stationary, then the forces acting on them must be balanced. So the forces upwards must be equal to the forces downwards, and the forces left must be equal to the forces right, if there are any. 3.1 asks us to complete a sentence. It gives us words to use. In stage 1, the downward force of the man on the bar is, well, we've just said he's stationary. If you're stationary, they must be balanced, hence it must be equal to the upwards force of the bar on the man. Otherwise it'd either be accelerating upwards or accelerating downwards. Next simple calculation, we have a man with a mass of 85 kilograms. There's a gravitational field strength of 9.8, and we need to calculate the man's weight. So weight is mass times gravity. Mass was 85. Gravitational field strength on Earth is 9.8. They usually give that to us, but if they do not, remember it's 9.8. And that gives me 833. You can always use your calculator. So 833 newtons. Here we have 3.3. A man raises his body a vertical distance of 0.63 meters to go from stage 1 to stage 2. Calculate the work done. We might have had to memorise this, but happily they've given us the equation we're going to use. So if they don't give it to you, you need to memorise it as work done is force times distance. What I'm going to do before I even attempt it is figure out what this force is. Now it's giving us a distance. That's pretty easy, that's 0.63. The tricky thing to realise is that the force is actually the man's weight. So whatever the guy's weight was, we're going to use as the force. Weight is an example of force. So we're going to need to take this value over 833 to this side. So work done is 833 times by the distance moved, which was 0.63. And 524.79. I'm just going to round that to 525 to the nearest 3 sig figs, so 525. The man was not moving in stage 2. How much work is done by the man at stage 2? So if you are not moving, you have travelled 0 meters. So if you look at our equation, force times distance, it doesn't matter what his weight is, it doesn't matter what his force is, because the distance moved is 0, he's not going to do any work. So our answer here is 0. Finally, a woman uses a bar to do a pull-up. The woman has a mass of 62 kilograms. She accelerates at 11 meters per second. Calculate the resultant force. And we're going to use force equals mass times acceleration, which is a quantitative look at Newton's second law of motion. So we have 62, the mass, acceleration is 11, 62 times 11, 682, and the unit is newtons. Let's write it down here.